In this lesson, we'll take a look at how to divide polynomials by two different methods, and we'll also show you how to use the remainder theorem. And before we start this algebraic example of dividing a polynomial by a binomial, I'm going to start with a little review of just dividing long division with numbers. So, let's say we wanted to divide 4 into 49. We would write it like this. That's the long division way. And so the first thing you do is divide this 4 over here into the 4 and the 49. And 4 goes into 4 once. And so I would write that 1 here. And so I take that 1 and I multiply it by this 4. 1 times 4 is 4. And we put that here. And we subtract. And so 4 minus 4 is 0. Or you can just leave that blank. And then the next thing you do is bring the 9 down. And so 4 goes into 9 twice. And so we would write that 2 up here. Now 2 times 4 is 8. So we put an 8 here. And we subtract. 9 minus 8 is 1. And of course that's the remainder. The remainder is 1. Now there's two different ways you can write the division statement for this. What's the relationship between the 49, the 4, the 12, and the remainder of 1? And so one way is you could write that 49 is the product of 4 and 12. Of course, that's only 48, plus the remainder, the 1, makes 49. Now, another way to write the division statement, which isn't written very much, but there is another way, is you could take that division statement and divide both sides by 4, by the divisor. And so after those divide out, another way to write this is that 49 divided by 4 is 12 plus 1/4, or 1 over 4. That's another way to write the division statement. This first one up here, though, is the way it's, and the most useful way it's written most of the time. So that's a review of dividing just with numbers in long division. Now, the long division with the algebraic expression looks like this. Same division symbol. We put the 2x cubed minus 5x squared minus 8x plus 15 underneath that symbol. And we're dividing by x minus 3. So the x minus 3 goes over here. Now, when you do the long division with the algebraic expressions, you take, and make sure this is written in order from largest power of x to smallest. And the same with the binomial. You don't want to write this as negative 3 plus x. X minus 3 is the preferred way. So what you do is you take that x and you divide it into the 2x cubed, the largest power of x here, largest, highest degree term. And so 2x cubed divided by x is 2x squared. Remember, you subtract the exponents. 3 minus 1 is 2. And now where you put that 2x squared is above its like term here. I wouldn't put it over the 2x cubed. You put it over the like term, the minus 5x squared. Now, same as before, with the numerical example, I'm going to take that 2x squared and multiply by the x minus 3. 2x squared times x is 2x cubed, and 2x squared times the minus 3 is minus 6x squared. And same as with the numerical example, we subtract. So 2x cubed minus 2x cubed is nothing. You can write 0x cubed if you want there, but you don't have to. And of course, we're subtracting these. Now, negative 5x squared, take away negative 6x squared. Taking away the negative 6x squared, same as adding the 6x squared. So this is really just negative 5x squared plus 6x squared, which gives you 1x squared, or just x squared. And then you bring the negative 8x down. Now I divide the x in the x minus 3 into the x squared. So x squared divided by x is just x, or 1x. And so we write that above the negative 8x here. So x times x minus 3 would be x squared minus 3x. Again, x times x is x squared. X times the negative 3 is minus 3x. And we subtract. The x squared, of course, are the same. Negative 8x take away negative 3x is the same as negative 8x plus 3x, which is minus 5x. And we bring the 15 down. Now, one more time, we're going to divide this x into the negative 5x, which gives us, of course, negative 5. And the negative 5 times x minus 3 is minus 5x plus 15. And so we subtract, and they're the same, so we get a remainder of 0. And so the division statement would look like this. We divided this cubic polynomial, third degree polynomial, by x minus 3, and our answer, our quotient, is 2x squared plus x minus 5. There is no remainder here, or the remainder is 0, so we don't have to worry about including a remainder here. Now, synthetic division is another way to divide than long division. And it's particularly useful, convenient, if you're dividing by a binomial that the coefficient's 1. It also works if the coefficient isn't 1, and I'll show that in another example as well. But it's particularly quick and useful if, as opposed to long division, if the coefficient of the x is 1. And so the symbol for the synthetic division looks like this. It's kind of a little bit like an upside down long division symbol. Notice what goes up here are the coefficients of the polynomial you're dividing the x minus 3 into. So the 2x cubed minus 5x squared minus 8x plus 15. Now we're dividing by x minus 3. What goes over here is the restriction in the division. And so since we're dividing by x minus 3, x cannot have a value that makes that divisor 0. And so if you want to find that restriction, you say x minus 3 cannot equal 0. And so solving for x, x cannot equal 3. That's the restriction of division, because 3 is the number that would make this factor 0. 3 minus 3 is 0. So we put a 3 here. And so notice it's actually it's always going to be the opposite sign of this. And so in synthetic division, what you do to actually do the dividing, similar to here, is you bring the leading number down, no matter what it is. Okay, bring the 2 down, and you go 3 times 2 is 6. So there's a 6 right here. So negative 5 and 6 add to 1. So we put a 1 here. And then we multiply that 1 by the 3, the restriction 3, which is 3, and add that to the negative 8. Negative 8 and 3 add to negative 5. And negative 5 times 3 is negative 15, and we add that to the 15 above it to get 0. That's the remainder. Okay, so what's to the right of this vertical line here? That's the remainder. Notice that the 2, 1, negative 5 are the coefficients of the 2x squared plus 1x minus 5. That's actually your answer. Okay, that's the quotient. Now, the 6, 3, and negative 15 actually do correspond over here. They are the opposite numbers of the negative 6x squared minus 3x and the 15. So here's the 6. It's the opposite coefficient of the negative 6x squared. The 3 is the opposite coefficient of this minus 3x, and the negative 15 is the opposite of this constant here. So there are counterparts in the synthetic to anything in the long division. And so I would write my division statement the same way. 2x cubed minus 5x squared minus 8x plus 15 divided by x minus 3 equals 2x squared plus 1x minus 5. After the remainder, these go in order. The constant, the coefficient of x, or whatever your variable is, the coefficient of the x squared, the x cubed, the x to the fourth, there's more, etc. Now, of course, the other way to write the division statement is that instead of writing it like this, we could have written that the original polynomial is equal to the product of the x minus 3 and the 2x squared plus x minus 5. And that's what this says here. And of course, the restriction, once again, is x is not allowed to equal 3. In example 2, we're dividing this cubic polynomial by x plus 2. Now, in this division, notice that there's no x squared here. And in division, you have to account for that. Same in a long division, you'd have to put a 0x squared there. And so we bring the leading 2 down and multiply that 2 by the negative 2, put negative 4 here. And so we add the 0 and the negative 4, which of course is negative 4. Negative 4 times negative 2 is 8, so we put an 8 here and add it to the negative 3 to get 5. And 5 times negative 2 is negative 10. Negative 4 and negative 10 add to negative 14. We didn't get a remainder of 0 in this one. So the restriction and the division statement would look like this. There's the restriction. X is not allowed to equal negative 2. That was our value we put here. That's the number that would make that divisor 0. And this is what the division statement looks like. The original polynomial is the product of x plus 2 and 2x squared minus 4x plus 5, and then plus the remainder, minus 14 in the end.